All right, so we're going to look at number 1. And let me tell you a couple of things that have already happened because I had some questions in math time about this. I had one student that had chosen y-axis symmetry for this. She substituted in like she's supposed to, and then with the y-axis symmetry, but it didn't work. She's like, I substituted in, but it didn't work. And I said, well, if it doesn't work, one of the things that's probably telling you is that your answer is wrong, right? If you substituted in and it doesn't work, then it's not y-axis symmetry. So does this have y-axis symmetry? You can tell by looking. No, because if it did, then when I reflect it, it would be over here, and that's not what's happening, right? That wouldn't look the same, okay? So does that make sense? You don't have the homework? So what'd you do with it? No, you didn't. I gave it to you yesterday, so there's no way you gave it to me yesterday.
Oh, the homework from last.
Yeah, the one you got yesterday. Yeah, there you go. All right, so what type of symmetry does this have? Origin, okay? So then let's talk about the work through this, because I want to work through this one with you as well. Has origin symmetry? If you are not sure, remember, you look at it, it's pointing up to the right and down to the left, and if you turn your paper 180 degrees, if it looks the same, still right here at the origin and everything, then it has origin symmetry. Then you have to test it. The test for origin symmetry is to replace the x and the y, right? So we're going to replace y with negative y, and that gives me 1/4, and we replace x with negative x, right? Oh, shoot, I did. I said 1/4, put 1/2. See, I wanted to see if you're paying attention. Good job, Tony. Thank you. All right. So that 1/4, I don't know, I'm making stuff up now. No room for creativity in math. So this negative y, I'm just going to leave that as negative y. And what is negative x cubed? Negative x cubed, right? So here's what I've seen a few times. People wrote this, and then they got confused, and they thought it was now magically 1/4 minus x cubed. Is that what happened? No, okay. So what's really happening is like you either need to put this whole thing in parentheses now or whatever, but that's still not how you would really leave it. Like if I was to write the equation for you, that's not how you would see it written, right? But since these two things are being multiplied together, can't I just pull that negative out front? So now I have negative y equals negative 1/4 x cubed. Now, does this look identical to this? No, but is it the same? Yes, why? Okay, because I could divide everything or multiply, however you want to think about it, by -1, right? And so if I multiply everything through by a -1, and the key with that, guys, is always everything. Like you can't just do one term on one side and, you know, there's only one term on each side, but you make sure you do everything, and then y equals 1/4 x cubed. Because your rule is, you know, whatever you do to one side, you do to the other. So if I multiply the left by -1, I multiply by the right by -1, they're still equal. Now it's identical. So I also don't want you to get to this point and then get stuck and think it's not working, because it does. And you know, if you're confident it has origin symmetry, then you should know going in it should work. So if it doesn't along the way, maybe something got messed up, or maybe you were wrong, or just maybe you're not finished and you can actually get there. Does that make sense? So I wanted to make sure that you could remember that if both sides are negative, that's what you end up doing. It's like when you get negative x equals -5, right? That just means x equals 5. It's the same thing. Okay, we good? All right, so let's look at the notes. So put that away, because I don't want you trying to finish this and not listening to what we're doing today. Oh, wrong notes. So this is what we had from yesterday, right? We talked about tests for symmetry, line symmetry, point symmetry, what you replace with. We just looked at an example and did one of those, right? We did a few more examples on the back. And then we get down here to where we stopped, even and odd functions. Keyword here being functions, all right? So even and odd functions are done in Algebra 2 sometimes. Pretty sure if you were in pre-AP Algebra 2, I'm pretty sure y'all talked about even and odd functions. I don't know if you do it on level or not. So this may be new, may not be new, but it's really not that bad. So we have a function. A function is even, okay? Something called an even function if it is symmetric with respect to blank. Okay, so that's symmetric with respect to. Sounds weird, but it's formal, and that's correct language for that. All it means is that it has symmetry, and it's either, you know, x-axis, y-axis, or origin. So a function is even if it is symmetric with respect to the y-axis. Okay? So if you have y-axis symmetry as a function, then you are an even function. Make sense? Okay? Now I want you to look up at the 4 pictures at the top. Are any of these even functions? Are any of them symmetric with respect to the y-axis? Yes. Which ones? 6? Anything else? 4? Think 4 is even too? Yes? No? Does 4 have y-axis symmetry? Yes. So why are you saying no? It's not a function. Okay? Remember I said keyword? This is why it's separate. This is why it kind of looks like what we did yesterday, but it's not, because those were just graphs. These are even and odd functions. And so this says a function is even if it is symmetric with respect to the y-axis. So even though this is symmetric with respect to the y-axis, it's not a function, so it's not even. If you're not a function, you don't get to be even or odd. If you are a function, you could be even, you could be odd, or you could be neither one of them. You don't have to fit into one of the categories, right? So even though it has to be a function. This is the only one of these 4 that is a function and is symmetric with respect to the y-axis. Does that make sense? Easy enough? Okay. So then we also have what's called odd functions. So a function is odd if it's symmetric with respect to, what do you think? Probably the x-axis or the only 2 things we have left, right? So could it be the x-axis? If I said you have to pick one and give me a good reason why it has to be one and not the other, without me telling you, what it is or anymore, what do you? Why? Why origin?
Because in the example above, there's a dash.
I've gotten that a lot. Yeah, I know. I need to change my blanks so that you're not going by the dashes. But could it possibly, tell me why it couldn't be the x-axis? Okay, and because it reflects it, it's not a function. Anything that has x-axis symmetry can't be a function because it will always fail the vertical line test. Does that make sense? And since we're talking functions, we don't talk about it anymore, right? There's reasons why it's important, and we did talk about it, but when you're talking even and odd functions, x-axis symmetry means it's not a function. So this has to be the origin. Okay, does that make sense to you? That's why there's only 2 here and not 3 like there was before. So you can visually look just like we did up there, but then there's also an algebraic check, because notice we don't even have graphs to look at down here. Okay, because it's nice that we had graphs on the other ones, because if I just gave you the function and no graph for the stuff we did yesterday, you'd have to substitute in a negative y, see what happens, substitute in a negative x, see what happens, substitute in both, see what happens. Basically, there's 3 sets of work for every single question because you have no idea what the answer might be. But that's not what's going to happen here because we only have 2 anyway. So we have the algebraic check is that we're going to look for f of negative x. And when we substitute negative x in, once we simplify it, if we get f of x and it's the same as what we started with, it's an even function. If we substitute in a negative x to find f of negative x, we get negative f of x, then it's an odd function. So the nice thing is they both start the same way, so I don't have to do 3 different sets of work. I'm just doing one, and the result I get is what tells me. If I get f of x, I'm good, it's even. If I get negative f of x, it's odd. If I don't get either one of them, then it's neither. Because again, it's not like I can separate every single function in the 2 categories. It doesn't work that way. Okay. So even or odd, this is our algebraic check. These are functions. Everybody with me so far? So let's try this. So for every single one of these, we are going to find f of negative x. So I'm going to start with number 7. We're going to do f of negative x equals cubed minus a negative x. Those of you that are sloppy with your work or think it's not important, you're going to be hurting yourself here. You've got to be able to follow. We don't have to, it's a million steps, but you've got to substitute it in and be able to read what you put. What's negative x cubed? Negative x cubed, right? And then what's negative negative x? Positive x. Okay. And so now that I've put it in, I've simplified it. When I look at this and I look at this, clearly they're not the exact same thing. So I know I'm not getting f of x. Is this equal to negative f of x? Watch what happens here. I know that this is my f of x, right? So negative f of x would have to equal negative x cubed minus x, right? So negative f of x is equal to when oh shoot. Do you see what I did wrong? I want to make sure you know what I did wrong and what I'm about to erase. This negative doesn't actually, I made that up again. Okay, negative, and then this is supposed to match that. That was my intention. Then when I distribute that negative, I get negative x cubed plus x. So this is what negative f of x looks like. Isn't that what I just got right here? So negative f of x is going to be when every single sign changes. Not just one of them, but it's basically like multiplying through by a negative 1. You with me? So what we got here then does equal negative f of x. So since f of negative x equals negative f of x, is it even, odd, or neither? Odd. So we say that this is an odd function, and then it says describe the symmetry. It starts the same way every time, and it's not that bad. We say that it is symmetric with, the way to abbreviate with, in case you don't know, because I use this a lot, is W with a slash. So symmetric with respect to, and is odd going to be with respect to the origin or origin? Odd for origin, right? Everybody okay so far? We are getting this, we're finding little pieces of things, right? We talked about in behavior, we talked about intercepts, we're talking about this, and we're going to put it all together here pretty soon. So I know it kind of seems like, why do I even care? We're getting there. We just got to learn what it is first. Mm-hmm.
So, in the thing right there, we tried to find f of negative x,
Mm-hmm.
and it didn't equal, so then we went to try.
Well, I didn't try anything else. Like, you don't have to do this over here. I was just showing you why it is equal. Okay, does that make sense? Like, you don't, this right here, you do not have to do. All you have to do is you substitute this in, this is what you get. Something identical, so you know it's f of x. If it doesn't look identical, it could be negative f of x. And so I just wanted to show you by working this one out that all that really means is multiplying through by negative 1. So since both signs changed, I could factor out a negative 1 if I wanted to, but we don't have to go through all that. That just means that it does equal negative f of x. Does that help? Okay, so y'all understand that? If it helps you to write that out so you know what it is, but you don't have to, okay? Are you good? You sure? Okay. All right, so let's look at 8. F of negative x, so all I'm doing is substituting in negative x. I've got negative and then negative x squared plus 6. First step, zero work, you just substitute it in. So what's negative x squared? X squared, right? But I have that negative sign out front, so that gives me negative x squared plus 6. I compare this to this. Does it look identical? Sure does. So that means that that is equal to f of x. And since f of negative x equals f of x, is it even, odd, or neither? Even. Okay? So it is even. And to explain the symmetry, it is symmetric. So I'm abbreviating symmetric with SYMM. Symmetric with respect to, and is it the origin or the y-axis? My only two choices. Y-axis. Okay, everybody good so far? All right, let's do number 9. Everybody with me? I want to make sure it's done writing. All right, number 9. So f of negative x equals negative x cubed minus negative x squared minus 2 times negative x. All I did was substitute it in, right? What is negative x cubed? Negative x cubed. Minus negative x squared is just x squared. Okay, but it's minus. This minus comes from here. This one gets taken care of and it goes away. And then negative 2 times negative x is positive 2x. So I compare these two. Are they exactly the same? No. Are they exactly opposite? Like, did every single sign change? No, so it's not the same as multiplying through by a negative 1. So it's not f of x, it's not negative f of x, so it's neither. Okay, and neither is a fine answer. Sometimes that's it. So it is neither. So it's either identical or basically every single sign changes. In a polynomial anyway, we'll look at something else that happens here in just a little bit. All right, y'all do number 10. I want you to do number 10. Give you a minute. All right, so I'm going to substitute in, I want f of negative x equals the square root negative x squared minus 4, right? So I take that negative x and square it. What does it become? X squared. So it's going to equal, don't lose my square root, x squared minus 4. Does that become x minus 2? No, absolutely not. No, no, no. Stop doing that. You do not get to distribute that square root sign, okay? You can factor this. This is a difference of 2 squares. I don't want to factor it here, but I can do x minus 2x plus 2. I can't simplify the square root. Plus, I don't want to because I want to take this and compare it to this. Does it look the same? Yes. So it is the same as f of x. So even though that one might look more complicated than some of the other ones, it was actually a little bit easier, and I didn't really have to do much. Is it even, odd, or neither? Even. Even. Good. So it is even. It is symmetric. Yes, you have to put both. Yeah. Well, thanks for your honesty. I wasn't even paying attention to you. So, respect to what? Symmetric with respect to what? Y-axis. Yes, because the directions say, tell if it's even, odd, or neither. If even or odd, describe the symmetry. So you have to make sure you answer the question first. Yes. We good? All right, we're going to do number 11 together. So f of negative x is equal to negative 8 over negative x. I just substituted it. I left off my parentheses there, but is that okay? Like in this case, it's fine. It doesn't change the meaning of it. So if you put them, great. If you don't, whatever. Can I simplify that? Yes. What does it become? Well, what happens when we have a negative over a negative? It's positive. So this is really just 8 over x. So obviously not the exact same as this f of x here. But is this equal to negative f of x? Okay. So I got no all day long when I got to these problems. But here's the thing. We've got some fraction issues we need to clear up here. Okay. If my f of x, and you might want to write this part down, x negative negative 8 over x. You have something like this. Do you take that negative and distribute it to the numerator and denominator? No, and here's why. Okay, here's why fraction knowledge is so important. This is really like a negative 1, right? It's not written, but we know it's a negative 1. If I take a negative 1 and I multiply it by negative 8 over x, every single time you ever multiply a whole number times a fraction, first of all, one of the things I might have fixed on some of your quizzes, and I didn't think to say yesterday, is you got to stop doing the slashy fractions. Like if you have 2/3, don't do this. You need to do this, okay? Because when you do all the time, things don't line up right. So that's what I mean by slashy fractions. Make them horizontal. I promise you it will help you, okay? You just got to, some of you got to train yourself. So over 1. And then you multiply straight across, and this gives me 8 over x, right? Does that make sense to you? So this is equal to 8 over x. So negative f of x equals 8 over x. So this is negative f of x. Now, do you have to go off to the side and do all this work every time? No, I was just trying to show you where it's coming from. Does that make sense to you? If you have a negative in front of a fraction, like if I had negative 2/3, sometimes things will be done that way. You could also write that as negative 2 over positive 3 or positive 2 over negative 3. Same thing either way, but it's definitely not negative over negative. Okay, we good? Fraction rules. If you don't know them or you struggle with them, go get them figured out. I mean, I cannot even stress to you enough how much that's going to help you if you struggle with them, because we don't have time to reteach 4th grade math. Okay. All right. So since it equals f of negative x, or I'm sorry, negative f of x, is this even, odd, or neither? Odd. So this is an odd function, and I say that it is symmetric with respect to the origin. Yes, good. Everybody okay with that? I'll take that as a yes. Let's look at 12. Thank you. So f of negative x is equal to the absolute value of negative x plus 1. Now, I left off my parentheses again, but does it really matter here? It does. So if you put them, great. If you didn't, whatever. Does this just become x plus 1 because it's an absolute value? No, because if it was just the absolute value of x, I could, but that's not what's happening here, right? I can't simplify this anymore. So not f of x, right? Is it negative f of x? No. So this is neither. And if you get confused on these, let me explain to you how you should be able to look at them from a parent function perspective. You did parent functions in Algebra 2. We're about to get back into them. There are some you should recognize. What does the parent function of an absolute value look like? Absolute value of, like if I just wanted y equals the absolute value of x, right? What does that graph look like? A V. Looks like this, right? Okay. Then when you did transformations, you could take that parent function, you can move it up and down, left or right, stretch it, squash it, whatever, right? So if you have something going on with x inside of here, well, first of all, this parent function, it's even, right? Because it's symmetric with respect to the y-axis. But when you have this kind of transformation is a horizontal one because it goes with x. And x lies, so this means I'd go to the left one. So what that one actually looks like then is this. And so that's not even or odd, right? That's why it's neither, because that's basically what this function looks like. So if you get confused in this, these types of things, you need to start being able to try and connect the pictures, at least the parent functions, because we're about to get back into those and you got to know what they look like. Okay? Any questions? Like, you don't have to know it for this problem, but I want you to start thinking that way anyway. Any questions at all? Are we good? Awesome. All right. So here's what I want you to do. We're going to look at